Welcome back. In this session, we'll explore how Retrieval-Augmented Generation, or RAG, stacks up against traditional generative models. Understanding these differences is crucial to appreciate why RAG is gaining so much attention in AI-driven applications. By the end of this talk, you'll clearly see how RAG addresses the key limitations of traditional models and unlocks new possibilities for AI systems. Let's get started. Traditional generative models overview. First, let's quickly revisit how traditional generative models work. Models like GPT-3 or GPT-4 are trained on massive datasets, learning the patterns and structures of language. They generate text by predicting the next word in a sequence based on the input they receive. While these models are incredibly fluent and versatile, their knowledge is fixed at the time of training. Once the training process is complete, they cannot acquire new information unless retrained. This means that traditional generative models are essentially static, and their understanding of the world gradually becomes outdated as time passes. Moreover, these models operate purely on the data they were exposed to during training. If the training dataset lacked information on specific topics or recent events, the model won't have the knowledge to address queries related to them. This can lead to inaccurate or fabricated responses, a phenomenon known as hallucination. How RAG differs. Now let's introduce Retrieval-Augmented Generation. The key differentiator of RAG lies in its ability to dynamically retrieve information during the generation process. Instead of relying solely on pre-trained data, RAG models pull in relevant documents or data from external sources in real time. Imagine asking a traditional model a question about the latest scientific discovery. If the discovery happened after the model was trained, the response will likely be incomplete or incorrect. A RAG model, on the other hand, can retrieve up-to-date papers or articles, ensuring that its answer reflects the most current knowledge. This retrieval component transforms generative AI from a static knowledge base into a dynamic, ever-evolving system capable of keeping pace with new information. Advantages of RAG over traditional models. Let's break down the core advantages of RAG over traditional generative models. Accuracy and factual consistency. By grounding responses in retrieved documents, RAG reduces the likelihood of hallucination. Traditional models can produce convincing but inaccurate information. RAG, by design, anchors its output to real, verifiable sources. Up-to-date knowledge. Since RAG can pull information from external databases, APIs, and other live sources, it remains current without the need for frequent retraining. This is invaluable in fast-moving industries like healthcare, law, and finance. Transparency and verifiability. One of the biggest advantages of RAG is traceability. The retrieval step leaves a reference trail, allowing users to check the sources that inform the generated text. This enhances trust and accountability, particularly in high-stakes applications. Cost-effective updates. Retraining large models is expensive and time-consuming. With RAG, updates can be handled by simply expanding or refreshing the knowledge base, significantly cutting down on the need for full model retraining. Real-world example. Consider a legal assistant AI tasked with summarizing recent legislation. A traditional model might summarize laws available at the time of training, but would miss new amendments or regulations. A RAG-based system can query legal databases in real time, ensuring that the summaries reflect the latest changes. Another example is in the healthcare sector, where RAG can provide clinicians with the most recent medical research, keeping them informed about emerging treatments without requiring AI model retraining every few months. Addressing potential challenges. Of course, while RAG offers numerous benefits, it isn't without challenges. One of the key issues is latency. Retrieving external information takes time, which can slightly delay response generation. However, advances in vector search technology and optimized retrieval pipelines are rapidly minimizing this issue. Additionally, ensuring the quality of retrieved documents is critical. If irrelevant or low-quality documents are retrieved, the accuracy of the final output can be compromised. This highlights the importance of fine-tuning the retrieval component and carefully curating the data sources. In conclusion, while traditional generative models have laid the groundwork for AI advancements, RAG represents a significant step forward by addressing their limitations. By integrating retrieval with generation, RAG ensures higher accuracy, up-to-date knowledge, and enhanced transparency, making it a transformative technology across industries. As we continue with this course, we'll dive deeper into the mechanics of building RAG models and explore hands-on implementations. Thank you for tuning in, and I look forward to our next session.